Good morning. So we've done multiplication and division of rational expressions. So the next natural thing to do is adding and subtracting them. So add and subtract rational expressions. And I think we don't have that much school left. I think we have about a week or so. You guys are so close to finishing Algebra 1. Hang in there with me. We're almost there. Okay, so say I'm adding A over C, just basic fraction, plus B over C, right? I can add common denominators. A plus B over C, where C can't be equal to zero. And if I'm subtracting, and I'll just do the subtraction over here, same idea, and C is not equal to 0 applies to both. A over C minus B over C is A minus B over C. We're going to use this same principle with rational expressions. So here's example 1. If I have 5 over 3x plus 7 over 3x. I know that I can keep this common denominator and add the numerators. 5 plus 7 over 3x, which gives me 12 over 3x. Once I've done that, I've got one more thing to do. I need to make sure I simplify it, and I know that 12 is 3 times 4, and this is 3 times x, so I can cancel, and my answer is 4 over x. Okay, let's do another example. In this case, instead of 3x on the bottom, we're going to do 3x on top and x minus 1 on the bottom. So this is A, this is B. And I'm going to subtract x plus 5 over x minus 1. Just as with any denominator, as up here and up here, I'm allowed to add these because they have a common denominator. So I have x minus 1 on the bottom, and on top I have 3x, but I have to remember to do this first. In other words, keep this in parentheses because otherwise you'll forget to use distributive property. So what do we get on top? 3x minus x minus 5, because I had to distribute that minus 1 in front to the x and the 5. And I have x minus 1 on the bottom. Now it's just a question of doing simplifying, and I end up 3x minus x is, I get 2x minus 5 over x minus 1, and I can't get any more simple than that, so that is my answer. The book says check your simplification using a graphing calculator just to see, and if you did and you checked it against graphing the original problem, you would see that it is correct. Okay, let's see. Let me just try one more of that's just like B, just to get you used to that, and then I will go on to example 2 and finding the least common denominator. So let's just try. Let's see, I have 4x plus 1 on top, and this is actually guided practice number 2. So 4x plus 1 over 2x minus 1. And I'm subtracting 2x minus 3 over 2x minus 1. Combining everything, I have 4x plus 1 minus 2x minus 3, keeping it in parentheses with 2x minus 1 in the denominator. I'm going to use my distributive property, so 4x plus 1 stays the same, but this becomes negative 2x plus 3 because of negative 3 over 2x minus 1. I'm going to simplify, and a 4x and a negative 2x gives me a positive 2x, and a positive 1 and a positive 3 gives me a positive 4. So 2x plus 4 over 2x minus 1. And just in case you wanted to know, this was guided practice number 2. Okay, let's move on to example 2. And here we're going to be talking about finding the least common denominator, because that's what we do when we add fractions. And so the ones that I just did already had common denominator, but we're not always fed such a nice problem. So to start, before we actually add or subtract, we're going to just work on finding the least common denominator. And let's look at the first. We're going to look at a pair of fractions, 1 over 4r and r plus 3 over 10r squared. And we're going to see, is there a least common denominator that we can find if we want to add or subtract these out of 4r and 10r squared, because we can't add or subtract them unless we do that. Well, to do that, there is kind of a systematic or careful way to do that. Let's take 4r and find all of its factors. 2 times 2 times r. And then let's take 10r squared, and we're going to find all its factors. 2 times 5 times r times r. And so we're going to circle these which are in common and these which are in common. And every factor that is in common, so to find the least common denominator, we're first going to take the 2 that were circled, so 2 times r, because we only have to use them once each because they're in common, and then we add all the other extra ones after. So we can now multiply everything together, and we know our least common denominator is going to be 20r squared. Let's look at another set. What is the least common denominator between 5 over x minus 3 squared and 3x plus 4 over x squared minus x minus 6? Well, we can't really figure that out unless we first factor this out. So let's do that. 3x plus 4 over, let's see, minus 3 plus 2, right? And this means this is x minus, there's 2, so I'm just going to rewrite this as well, just to keep track of the fact that this x minus 3 and x minus 3. Okay, so now I can write over here what is each of my factors. So the factors for the first denominator for x minus 3 squared is x minus 3 and x minus 3. And for the second denominator, which was x squared minus x minus 6, it's x plus 2, x minus 3. So what's my LCD? I use the exact same process that I did above. I can see that these are in commons, and so I write that one down once. And those that are not in common, I have to include all of them. So x minus 3 at the second x minus 3 and x plus 2. And so my LCD is going to be x minus 3 squared times x plus 2. Let's look at one more before we leave. And that is, I have 3 over c minus 2, and c plus 8 over 2c plus 7. Well, here, if I try to find the least common denominator, I can't break either of these down any further than they already are. So this is actually an easy one to find, that the LCD is just going to be a combination of both c minus 2 and 2c plus 7. I'm going to pause here and stop the video, and because this is new and sometimes a little difficult, well, it's not new, but it's new in this format, I am going to do guided practice 3, 4, and 5 as I did. They're optional, as I did in the last lesson, and I'm going to go through them quickly. So pause the video and do them, and when I come back, I'm going to work them out for you.